Okay, so here we go. We're doing right triangle trigonometry. This is the basic stuff that we covered last year in geometry, and I don't know, maybe some algebra. Did you do any of this in your Algebra 1 class? Probably not. Well, I'm asking not everybody, because not everybody had a good geometry or Algebra 1 class. But yeah, this is probably not something you would learn in Algebra 1. Okay, it's definitely something in geometry, which we did, and we had to skip ahead to get to it, right? Because it's at the end of the chapter. Same thing here. This is pretty much towards the end of the chapter, or at close to the end of the chapter. But I always try to skip ahead because I just think it's important. I really do. Especially if you continue in your math, if you continue in pre-calc, in calculus, especially in calculus, you really have to know this stuff, right? So I want you to be a little bit prepared so you're not learning it for the very first time when you take calculus. That would be kind of rough. So here we go. It's right triangle trigonometry. We are going to do some stuff that we did not do, I don't think. Did we do law sines, law cosines? No. I think we might have. Yeah, I think we might have. But anyway, this stuff right here, the SOHCAHTOA stuff that you guys mentioned, because you already saw this before, right? So that's only with right triangles, all right? So we're only dealing with right triangles today. We will eventually branch off into other ones. So let's name this thing. Let's call this ABC. I'll try to go through this first part kind of quick. I want to get to the examples. And let's deal with angle A. All right, so I'm dealing with angle A. So this side right here, what would I call this side right here? AB. It's opposite the right angle, so it's always the what? The hypotenuse. Doesn't matter if I'm dealing with angle A or angle B. This is always the hypotenuse. Now, how do I refer to this side BC? It's opposite of angle A, so this would be opposite. And again, I'm dealing with angle A right now. Okay, what is this side, this AC? What is that to this angle right here? It's next to it or adjacent to it. So I'll put ADJ, all right? ACENT is how you spell it. But adjacent means next to, all right? So this is the adjacent side. That's the opposite side. That's the hypotenuse. But what if, I'll tell you what, instead of writing a separate triangle, I'll do it in different colors. What if I was dealing with angle B? This would still be the hypotenuse, wouldn't it? Okay, so that wouldn't change. Why? Because it's always opposite the right angle. All right, just because I'm dealing with angle B doesn't change the fact that this is opposite this 90-degree angle. But this side right here is not adjacent to the yellow angle, to angle B. What is it? It's opposite, okay? Everybody see that? So depending on what angle you're dealing with, this could be adjacent or could be opposite. All right, what is it? This is opposite angle A, but what is it to angle B? It's adjacent, so that would be adjacent, all right? And if you want to put, it's both, right? It's the white one and the yellow one. This is the hypotenuse. All right, all depends what angle that you're dealing with. So here's what we're going to do. These words, and you already know it already, but I'm going to say it anyway, okay? We're going to talk about the sine of an angle. We're going to talk about the cosine of the angle. We're going to talk about the tangent of the angle. What does this mean? What are these crazy words that we never use in regular life? What does it mean? It just means it's talking about the ratio of two sides of a right triangle. When I say ratio, it's a comparison between one side and another side. That's all it means. Now, the sine is a comparison between two distinct sides of a right triangle, right? The sine of a particular angle is equal to the opposite side divided by the hypotenuse. That's what the word sine means in trig. It means you're going to take the opposite sine and divide it by the hypotenuse. The sine is not a variable. You can't divide by a sine. You can't multiply by a sine. Okay, the sine just means that you take whatever angle that you're dealing with, like the sine of angle A, is equal to the opposite side divided by the hypotenuse. That's what we're talking about. The cosine is another word that describes a ratio between two sides of a right triangle. Okay, in this case, the cosine is the adjacent sine over the hypotenuse. Where are you going? Baseball again? Are you ever in this class? All right, it's being recorded, so watch it and do the homework. Okay, so now the tangent means the opposite side divided by the adjacent side. All right, so the word sine means the opposite divided by the hypotenuse. The cosine means adjacent over hypotenuse. The tangent means the opposite over the adjacent. So if I wanted to, let's not get real specific yet. Let's do this. Here's another way you could write it. Instead of writing out the whole word sine, we shorten it to 3 letters. And it's really the first 3 letters of all of these. So we put S-I-N. It's not sin. People want to say that all the time. Nobody ever says that. Never heard a math person say the sin of an angle. We always say what? The sine of the angle. Even though we write it S-I-N, we say sine. Everybody got it? It's just a shortened version of this word. All right? So the sine is equal to, instead of writing OPP and HYP, I'm going to write it like this. O over H. Usually I do this in capital letters. Let's do it. Well, I guess that S could be a capital, couldn't it? So I'll just say the sine is equal to the opposite. Let's do it like that. I don't know. Is equal to the opposite over the hypotenuse. Or you could say S equals O over H. The reason I'm doing that is to do the SOHCAHTOA thing. All right. And then the cosine, we just use the first 3 letters. Again, we don't say cos. I mean, I have heard people say that, but it's not common at all. But just say cosine, all right? It's not that much harder. So say the cosine of a particular angle. And again, it depends which angle you're talking about. You're not going to take the sine, cosine, tangent of this 90-degree angle, just the 2 acute ones, okay? We'll do that in a second. So the cosine of a certain angle is the adjacent over the hypotenuse, or I could just write C equals A over H. You see where I'm going with this, right? All right, and then the tangent, use first 3 letters, so we just use tan. Now, in fact, I've been teaching this in my honors geometry class already. And today I actually said the tan of the angle. So there are times where I might say tan just to be a little shorter, but technically that means what? The tangent. All right, so that's the opposite over the adjacent, or T equals O over A. Now, if you look at this, how do you remember what these trig functions are? How do you remember that the sine is the opposite over the hypotenuse and so on? There's a little device. It's called a mnemonic device. It starts with an M, but the M is silent. I don't know why. English is really weird sometimes. Mnemonic. It's called a mnemonic device, which just means the letters all stand for a word, right? We've already done that before. Please excuse my dear Aunt Sally. Remember that? PEMDAS. All right, we've done mnemonic devices before. But what is this one? This is so, and then ka, and then toa. When I learned this in high school, my teacher said toa soka. That's what he always said. All right, it sounds weird now because we always say SOHCAHTOA, but he always said toa soka. All right, how it doesn't matter. Does it really make any difference? No, but that's how you remember it. The word so doesn't really mean anything, but if you remember so and then ka and then toa, that tells you that the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. We will. We're going to learn about that today. All right? So that's something that's very nice to use. All right? And let's see what else I want to do with that. Nothing. Let's go to an example. Ashton earlier says I love that SOHCAHTOA stuff. All right, so, and a lot of people do. A lot of people kind of like this. And I think some of you guys even mentioned when we say we're going to do trig, like, I like doing that stuff. It sounds hard, trigonometry. It sounds really difficult. But really, when you first start, later on it gets a little bit difficult, okay? But right now, it's pretty easy. And yeah, I think this is something that you should look at and say, yeah, I can handle this. This is kind of good. Obviously, anytime you do something in math, it's going to get more difficult as it goes on. So that should not be a surprise to you. Okay, here's the kind of questions they're going to ask. This is basically just to test to see if you know your SOHCAHTOA stuff, all right? That's basically what it's doing. So the question says, state the 3 basic trig functions. State the 3 basic, actually they say ratios instead of functions, basic trig, right? Trig, short for trigonometry. I think you understand that. Basically, trigonometry is the study of angles, all right? And that's what trigonometry is all about. The trig ratios of both of them, angle S and angle T. There's no really work involved. You don't have to worry about doing any math with this. All we're doing is just writing the ratios. We're writing opposite over adjacent, opposite over hypotenuse, adjacent over hypotenuse. But we're actually putting the values in for the opposite side, the adjacent side, and the hypotenuse, okay? So what are my 3? It's the sine. What do you want to do first? Angle S. All right, so the sine of S. We always do that. It's always the sine of an angle. You never take the sine of a side. You always take the sine, cosine, tangent of a particular angle, because you got to know what angle you're dealing with, and then you can go opposite, adjacent, hypotenuse. Everybody see that? So you always take the sine of an angle. I can repeat that 100 more times, and it might not be enough, all right? So just remember, you always take the sine of an angle. So the sine of angle S. Let's put some numbers in there. Well, first of all, what is sine? That's SOH, S-O-H, opposite over hypotenuse. So to angle S, which one is opposite? 12. Which one's hypotenuse? 13. So we write what? 12 over 13. That's all they're asking you to do in this problem right here. It is. All right, let's do the cosine of the same angle, the cosine of angle S. So again, we're dealing with this angle. So what's the cosine? It's the ca, C-A-H, right? So ca toa, C-A-H, adjacent over hypotenuse. Which one's adjacent to angle S? 5. Which one's hypotenuse? 13. So it's 5 over 13. And we're going to use this, okay? We're going to use this to actually find angle S. All right? And it can be very, very helpful. Because without trig, is there any way that you would be able to figure out what either one of those angles are? Now, if you found one, you could find the other pretty easy, right? But just finding the one without trig, you wouldn't be able to do it. But now we can. All right, what's the last one? Tangent. So let's take the tangent of angle S. Tangent of angle S is opposite over adjacent. So which one's opposite? 12 over adjacent, 5, 12 over 5. Good. Let's do angle T this time. So now we'll stick with sine, cosine, tangent. So the sine of T, we'll do the cosine of angle T, and then we'll do the tangent of angle T. Again, remember what these words represent. They just represent you putting one number over top of another one, right? And they're kind of telling you which one to put on top, which one to put on the bottom, right? Everybody understand that? So the sine is kind of like a secret word between us. That means we're going to take the opposite side divided by the hypotenuse, all right? So let's do it. Angle T, this one down here. Now, which one is opposite angle T? 5 in the hypotenuse, so it's 5 over 13. I want us to, when we finish these two, I want us to compare this to this, all right? Maybe do it in your head already. The cosine of T. Cosine of T is the adjacent over the hypotenuse, so that's 12 over 13. And then the tangent is the opposite over the adjacent, so that's 5 over 12. Do you see any kind of similarities? Yeah. Look, the sine of this angle is the same in this one particular triangle. The sine of angle S is the same exact value as the cosine of the other angle. When I say the other angle, I'm talking about the other acute angle, okay? Not the 90 degree, just talking about these two. Everybody see that? So those are the same. So the sine of one angle is equal to the cosine of its complement. Aren't these two complements of each other? Yeah? All right. So you understand what I just said there? It's pretty important. The sine of one angle is equal to the the cosine of the complement of that angle. Right? Okay. Look at this. The cosine of the angle S is the same exact thing as the sine of angle T. So again, the cosine of one is equal to the sine of the complement of that angle. All right? Because S and T are complements. Look at the relationship between the tangents. They're inverses of each other. 12 over 5, 5 over 12. Okay? So the inverse or the tangent of one angle is equal to the tangent. How should I say this? The inverse of one angle. I don't know how to say it real nice and pretty. But the tangent of one is equal to this, and the tangent of the complement is equal to the inverse. There we go. Of this original tangent. Just take the inverse, okay? One to the other. Everybody good with that? Yeah. Yeah. I wrote something down, but I don't think we need that now. All right. All right, you asked for this. Now you get it. So what we're going to do now is talk about the reciprocal. They say reciprocal. I always use the word reciprocal. Reciprocal, or the inverse of the trig function. So now we're going to do inverse trig functions, or trig ratios. They use the word ratios. It's fine. Usually say trig functions, but that's fine. The reciprocal or the inverse trig function. So watch what we're going to do. The reciprocal. Let's start with sine again. And this time, I need to put an angle here, an unknown angle. You okay if I use theta for that? All right. So instead of saying theta is equal to something, what I'm going to do now is figure out what 1 over the sine is. Well, we have a special name for that. Instead of just saying the inverse of the sine or 1 over the sine, we have a special name for this, and this is called the cosecant. I'll write the whole word out. Okay, it's called the cosecant. Now, we're not just going to use the first 3 letters, because if I use the first 3 letters, that would look like a cosine, wouldn't it? Okay, so I use CSC. Is that all right? Of the angle. So look, the cosecant of an angle, that's a word I don't think we did last year, did we? The cosecant just means the inverse of the sine, 1 over the sine. That's all that means. The reciprocal, right? Or inverse. That's why I put the or right there. That's all that means. Let's do the inverse of the cosine. So that would be the inverse of the cosine, or the reciprocal of the cosine, right? 1 over cosine. And this is equal to the secant. Now in this one, we do put the first 3 letters. S-E-C. So the secant of an angle is just 1 over the cosine of the angle, or the reciprocal, right? So if I know the numbers, like 3 over 5 or whatever, I would just flip. Make sense? All right. What about this one? 1 over the tangent of an angle. That's called the cotangent. All right. Co, I believe, like complementary, it's got the CO on there. It's kind of what that refers to, okay? Is the the complementary of this. Just kind of like what we saw before. On this one, we can put the 3 letters, the first 3 letters, cotangent, all right? So again, the cotangent is just the reciprocal or the inverse of the tangent, 1 over. And I understand why they use reciprocal, because we're going to do something else with the inverse. It's not exactly the same as this. So I understand why they use the word reciprocal instead of inverse. All right. Now, do I have a special SOHCAHTOA thing for the cosecant, secant, cotangent? Nope, I don't. I just remember that they're inverses. So if I wanted to do the cosecant, oh, by the way, let me say this. How do you know that the cosecant goes with the sine and the secant goes with the cosine? Because remember, they're inverses of each other. A lot of people think the secant and the sine are inverses of each other because they both start with the same letter. And the cosecant and the cosine are inverses of each other. But since they're inverses of each other, are they going to start with the same letter? Nope, they start with the other letter, okay? You follow me on that? It's not why they named it, but that's how I can remember which one goes with what. So the cosecant doesn't go with the cosine, it goes with the what? It goes with the sine. Remember that? Okay? The secant doesn't go with the sine because it's the same letter. Since they're inverses of each other, it goes with, when I say it goes with, doesn't mean they equal, but they're inverses of each other. It's the inverse of the cosine. You get it? So the inverse of the cosine and the secant, they go together. right? And the sine and the cosecant, they go together. Again, when I say they go together, doesn't mean they're equal. It means they're inverses of each other, okay? So let's do the cosecant. Without looking at all this stuff right there, don't look. Here, we'll do this. There, don't look. Is that better? Where are you going? Girls soccer. Thought you played boys soccer. Are you one of those that want to play both? Oh, I know. I'm just giving you a hard time. All right, have fun. Good luck. All right, so the cosecant. Let's do the opposite hypotenuse adjacent thing. So the cosecant goes with the sine. So what was the sine? Opposite over hypotenuse. So what's the cosecant going to be? Hypotenuse over opposite. Again, don't try to remember any mnemonic device, any trick to remember these. Just remember they're inverses of each other. That's all you remember, okay? So I look at this and I'm like, oh, cosecant, that's the inverse of the sine. Sine is opposite over hypotenuse, so the cosecant's hypotenuse over opposite, all right? Literally, when you think of that in your head, after you get used to it, you can do that even quicker than that. What about the secant of an angle? The secant's the inverse of the cosine. The cosine is adjacent over hypotenuse. So what's this going to be? Hypotenuse over adjacent. See how easy that is? Tangent, super easy. Well, actually, cotangent. Cotangent. Again, the tangent is opposite over adjacent. So what's this going to be? Adjacent over opposite. And you would rarely have to remember these, all right? If they do give you the secant, you just know that it's the inverse of the cosine. If they give you the cosine or the cosecant, that's the inverse of the sine. And the cotangent's the easy one, because they both have the word tangent in there. And there you go. Everybody good with that? All right. We're not really going to use this stuff right now. Maybe later on we will, okay? But for right now, we'll just kind of put that on hold. At least we learned it. We got it in the back of our head. When we get to the point where we're going to use it, then we'll use it. Everybody good? All right, let's do a little bit more. Let's do some real stuff. Instead of just writing down your trig functions and all that, I mean, that's good to do, and it's good to know, but I want to put this into practice. I want it to be practical, okay? I want to actually solve for some stuff using this trig ratio thing that we're doing. So I'll draw the triangle the way they do. They kind of draw it like this, and I don't know, does that look like a right angle? Pretty close. All right, we'll say it is a right angle. There we go. So there's your right triangle. They put these letters, I'll use the letters they use. All right, they say this is 1, this is 2, and this is h, little h. Since that's big H, that's little h, right? Because they're opposite each other. And what we need to do, well, actually right now, I just said we're going to actually solve for some stuff. We're really not solving for anything right now. We're doing one more prep thing before we actually start solving for some stuff. But I think this is important. I don't think this is a waste of time. So it says state the exact value, which means we're not using a calculator, we're not using decimals, okay, of the 6 trig ratios this time. Well, that other one said 3 because we didn't learn the inverse ones, right, or the reciprocal ones. So now we got 6 altogether, right? We got sine, cosine, tangent, and then we got cosecant, secant, and cotangent, all right? So find the exact 6 trig ratios of angle H. So you're not doing this with 2 of them like we did earlier. We're just going to do angle H. That's good enough. So let's use this angle right there, and let's do all 6 of them. They like to start with the sine. And again, we're doing the sine of angle H. We'll do the sine, cosine, and tangent of angle H. And then let's write the inverses over here, the reciprocals. What's the reciprocal of the sine? I'm going to give it some room. Cosecant of H. And then we're going to do the what? Secant of H. And then we're going to do the cotangent of H. All right. Once we get the sine, cosine, and tangent, Then the inverse ones or reciprocal ones are easy. We just take them and flip them, right? But this is a little trickier, just a little trickier than what we did with that 5, 12, 13 one, all right? First of all, they don't give us all three sides. So I got to find this. How do I find h? What? How do I find h? Pythagorean theorem, that's right. Okay, you guys are all worried about trig function, right? Trig stuff. But yeah, this is just basic right triangle. I got two sides. How do I find the third side? Do Pythagorean theorem, all right? So let's do that. Let's go h squared plus 1 squared equals 2 squared. You might even be able to do this in your head. What's that? 4 minus 1 is 3. Take the square root. What is h? Square root of 3. Good. Put that right there. So now we got all three sides. Now I can do all my stuff. Okay? Because I needed that, didn't I? Because that's my opposite, and I use opposite quite a bit, so I gotta have that. All right, let's do the sine. What's the sine? Opposite over hypotenuse, so what is it? Square root of 3 over 2. I'm not going to get into it right now, but that number, square root of 3 over 2, is a super important number for what we'll probably do a little bit later if we have time to get to all this stuff, okay? So square root of 3 over 2, that's a popular number. It really is. It's not just some random thing. It's something we're going to use quite a bit, right? Again, I'm not going to get into it, why, but just kind of put that in the back of your head. Remember square root of 3 over 2. What's a cosine? Cosine is adjacent over hypotenuse. So what's that? That's 1/2. That's another number that kind of goes with the square root of 3 over 2. Is that 1/2? All right? Again, just remember, when we get to it, we'll come back to this and I'll say, hey, do you remember with that square root of 3 over 2? That was an important number. Here we go. Here it is. And that 1/2 is an important number. There it is. Okay, we're going to do some stuff with that later. What about the tangent? The tangent of angle H is opposite over adjacent. So that's easy. It's just what? Square root of 3. You could put over 1, but you don't really need it there. Now, let's do these over here. Now, this is a little bit more complicated. I'll tell you what, I pushed these all the way over. I actually needed more room to the right. All right. What's this? The cosecant. Well, the cosecant is the inverse of the sine. So how do I write that? I just flip 2 over square root of 3. But little problem with that. What's the problem with that? Square root on the bottom. So we're going to rationalize the denominator. Multiply the bottom by square root of 3, the top by square root of 3. Let's do that in our head. You guys are good enough to do that, right? So what do we get? 2 square root of 3 over what? 3. Okay? So that's the inverse of this, or the reciprocal of that. Right? Secant's the reciprocal of the cosine, so that's easy. What's the reciprocal of 1/2? It's just 2. So the secant of that angle would be 2 over 1. Let's do the cotangent. Well, this is square root of 3 over 1, so what's the inverse? 1 over the square root of 3. Rationalize the denominator, we're going to get square root of 3 over 3. So there you go. There's your 6. 1, 2, 3, 4, 5, and 6. Everybody okay with that? I know I'm going fast, but I have a lot to get through, and I want to make sure that I get through everything. Still good, 10 minutes. You know what? We're still not really solving for stuff just yet. So really this lesson's kind of, it's not, I wouldn't say it's just an introduction. It's a foundation. That's a better word to use. Okay, it's a foundation type of thing. Now this time, we're going to do the same kind of deal. It's not a ton different than what we just finished doing. So there's my right triangle. And I'm going to make that 3. I'm going to make that 5. Now I'm going to introduce, we may have used this letter before, an alpha. You know alpha, right? You've heard of that? Alpha, omega, beginning and the end. It's the first letter of the Greek alphabet, and I kind of draw mine kind of like that. All right, that's my alpha. If you look it up in a book, it might look slightly different, but it's kind of looks like that. Almost like a little ribbon, almost like half of infinity, maybe the fish thing. Yep, kind of like that. All right, that's an alpha. It's just like a theta, just like an angle A. It doesn't matter. It just represents, just a letter that represents this unknown angle. All right, and I'll call this C right there. Now, this is a little different. This one, they kind of tell you, well, they do tell you the tangent of the angle. All right, the tangent of this is equal to 0.6. Now, we haven't dealt with decimals yet, have we? Everything we've been doing is a fraction. It's a ratio, right? Comparison of one thing to the other. So let's change this into a fraction. It's way better. It's way easier to change that. So what is 0.6? Well, it's 6/10, isn't it? What is 6/10? 3/5. Now, watch very carefully. It says the tangent of this angle is 3 over... Oh, you know what? Daggone it. I skipped ahead. I had this in my notes because I put it on after this. Pretend I didn't put the 3 and the 5 there, right? So it says the tangent of this angle is equal to 3/5. So they're not going to put the numbers with a triangle like I did earlier. I got ahead of myself. But the tangent is 3/5, which means this is the what? Opposite, and this is the adjacent. To what? What angle? This angle alpha right there, all right? So what is the opposite? This side right here, so that would be what? 3. This is the adjacent. It would be this side right here. What would that be? That would be 5. So that's where you get the 3 and the 5. Sorry about that. Make sense? Now, this, of course, is a 3, 4, 5 triangle. So this is 4, correct? Why? Is it 6? You sure? It's not 3, 4, 5. Why is it not 3, 4, 5? Because if it's 3, 4, 5, the 5 would have to be the hypotenuse. Okay, so it's not a 3, 4, 5. I did that to try to trick you up a little bit. Okay, so how do I find C though? Yeah, do Pythagorean theorem. So let's see. C squared equals 3 squared plus 5 squared. That's 9 and 25, which is what? 34. Take the square root. So C is the square root of 34. Now, they're going to ask you what they asked you earlier in the last example, okay, for the 6. They already gave you 1, right? They already gave you the tangent, right? And you would just say 3/5. Always reduce it. Make it 3/5. We just have to find the other 5 now, all right? So let's do that. So sine of alpha, cosine of alpha, tangent of alpha. And they also ask you to write it as an exact value and a decimal approximation. All right. I don't have enough time to go through all of that. I'll just get you started on this. Okay. I'm not going to do this whole thing because I got to get to something else before class is over. So let's do at least a couple of these. Okay. What is the sine? Now we know all 3 sides. I should be able to find the sine. So it's what? 3 over what? Square root of 34. It's opposite over hypotenuse. Everybody see that? All right. We don't keep it like this, though. What do we do? Rationalize the denominator. So that's 3 square root of 34 over 34. Can you go from here to here in your head right now? Just multiply top and bottom by square root of 34, right? So that'd be 3 square root of 34. If I multiply the bottom by the square root of 34, it just comes out to 34. Yeah, you should be able to do that at this point. Do the same thing for cosine and for that. How do I find, what's the inverse of the sine? It's the cosecant. So the cosecant of alpha would be what? Just take this and just flip it, right? So this would be square root of 34 over 3. And you can do the same for the others. You can do the rest, can't you? How do you find a decimal approximation? Put it into a calculator. It's easy as that, okay? You just put in square root of 34 over 3, put it into a calculator, and I do have it written down. I'll just do these two. So it's 1.9. They take it to 4 decimal places. All right, and then if you're going to do this one, this comes out to 0.5145. All right, you can do the rest. It's in the book, all right, but that's what they want you to do. All right, let's go to a calculator now. You can do a lot of this stuff in a calculator. So I'll bring up my little virtual calculator. What do I always have to do with this calculator first? Put it into degrees, yeah. Now, if you've already got yours in degrees, it probably will stay there unless you like take the batteries out or something. All right, but on mine, It doesn't. So I got to change it every single time. So the first question says, find the sine of 60 degrees. On a calculator like this, we actually hit sine first, and then we hit 60. I like to close the parentheses. I don't think you really need to, but it just looks cleaner to me to do that. So I do, and then I hit that, and boom, there it is. So it's, again, it's approximately, because that doesn't stop at 8. It keeps on going forever. So it's 0.8660. A lot of times they want you to take it out 4 decimal places when you use this trig stuff, okay? All right, that was easy, wasn't it? The next one says, find the tangent of 22.6 degrees. Same exact type of thing, except this time we hit tangent, you hit 22.6, and then hit enter, and there it is. It's I guess you could put a 0 in front of it. 0.416 what? 3. Good. 416.3. Again, it's approximately equal to. I don't really care if you put the approximate or not, but as a teacher, I guess I need to. All right, now, this calculator doesn't have a secant button, so you have to know something about the secant to be able to do this. All right, 83.25 degrees, and you want to find the secant of that. But remember what the secant is the inverse of, or the reciprocal of. It's the reciprocal of the what? The cosine. So we could write it like this: 1 over the cosine of 83.25. Yeah, that's a different thing, though. Yeah. Yeah, it's not the same thing as this. I don't think it is. Right, it's not. It's something else. Okay, we're going to do that maybe even tomorrow. Okay, we'll use the second function, but that's not what this is. That doesn't give you the secant of this. All right, it's something different. We'll talk about it then. So what you could do is just do this. Put 1 divided by, and then hit cosine and 83.25, close it, and then you get that number right there, 8.5079. 8.5079. Okay? So that's how you use a calculator for that kind of stuff. All right, I got one more thing. Here's something. We got like 3 minutes. Ugh. You know a clock, right? You got 1 hour. All right, how many minutes in an hour? 60. How many seconds in an hour? 360? Yeah? Come on, somebody tell me how many seconds? 60 times 60. Right, 3,600. Right, 3,600. So what we have is, I'll keep that calculator there. We have degrees, and we've already done that. We did that, 83.25. But sometimes they don't put it as a decimal. Sometimes they write it in different units. So you have a degree, and you have minutes, just like a clock, but you're talking about parts of 1 degree of an angle. All right, and then you have, what do you think the other one is? Seconds, okay? Very similar to a clock. But we're not talking about time, we're talking about 1 degree. So watch, if I had, let's say that was 1 degree. It's pretty big, but let's say it was 1 degree. If I broke this into 60 parts, then each of those parts would be 1 what? 1 minute. If I took one of those minutes and I broke that down into 60 parts, then that would be 1 second. You see that? All right, so that's what we're doing here. So 1 minute, let's do this. We show minute like this. We put a little tick mark, a little slanted thing like that. That's 1 minute, and that's equal to 1 degree divided by 60. You with me on that? 1 second, what's a second? It looks like this. It's like a double tick mark thing right there. That's 1 second. What do you think that is? That's 1 degree divided by 3,600. So if I took 1 degree, all right, and then I divided it 3,600 times, what is each of those angles going to be? 1 second. Okay? Let me do this one example real quick. Just hang on. Give me like 1 minute. You should be able to get to class in time, right? in 4 minutes instead of 5? I think so. So let's do this. Watch. 36 degrees. Now, how do I change it from minutes to degrees? I would go 40 over what? 60. And I'm going to add these all together. Then I'm going to take the 20. This is in seconds. And I divide it by what? 3,600. Now, put that into a calculator. Put that into a calculator. Add them together. Add them to 36. And you get like 36.6722. See, it's still 36 degrees, isn't it? But it's 0.6722 degrees. That's what this comes out to be. So that's how you do seconds or minutes and seconds. All right. Whatever I gave you your lesson plans. Didn't I put it on the screen? I didn't put it on the screen earlier? All right. Well, no, we have it. We have it. Too bad. 1 to 29 odds. 1 to 29 odds. 1 to 29, just the odds. And this is section 10.1. There you go. There's your homework.